Hi everyone, thanks for being here. So, as she said, my name is Andrea Grandi. I work as a Python Django developer for government digital service. It's basically the digital part of government in UK. Um, I'm passionate about IoT, Arduino, Golang, and machine learning. But more important than who I am is who I am not. So the point of this talk is basically this one. I'm not a data scientist. I don't have any degree in, especially in math or statistician. So um, I've been doing machine learning for not more than 1 year. So I'm really junior in this field. So why this talk, you may wonder. I decided to prepare this talk because after studying machine learning for a little bit and applying in at least a couple of work projects, I wanted to make sure that also other developers could start doing some practical things on machine learning. And at the beginning, I was also scared about this area. I didn't know much. I didn't know where to start from. I was really missing a starting point to start practicing and to start doing something useful with machine learning. So I hope this talk can inspire you at least to have somewhere where to start. Um, my advice is start doing something that is useful, and then you can take care of the theory right after, so you can study more theory after. Um, so what you're going to learn with this talk? Well, you will learn how to approach a problem, how to study the available data. We'll see what kind of data we have. Find the best algorithm. You will learn what does it mean, finding the best algorithm. And then you will make a prediction. So you will use your trained model to make a prediction. In a simple way, because I didn't want to make things difficult. I want to make things simple for you. So if you all can understand how to do something similar at the end of the talk, I'm very happy, because it means that the talk was successful. So before starting, just a little bit introduction on theory, but don't worry, I won't spend too much time on this. So what is machine learning? Basically, machine learning is when you can teach a machine, a computer program, to work on data that this program have never seen before. Normally, you are used to program every step of your application. If this happens, then do this. If these other things happen, then do this other thing. With machine learning, basically, you teach your application a method. With this method means that your application is able to kind of reason on the data you give it. And after that, if you give the model data that the model never seen before, you will be able to use that data in a proficient way to make, in this case, like a prediction. So machine learning. So we have usually two types of learning, the supervised learning and unsupervised learning. Now, in this presentation, we will concentrate on the supervised learning. So what does it mean, supervised learning? Supervised learning is basically, imagine when you want to learn about, for example, if I show you a picture of a dog, you know that that is a dog. How you know it? Because during your time, you have seen many dogs around, you have seen many pictures of dogs. So when you see one, now you know that that is a dog, and that is not a cat. So that's basically the same principle behind machine learning. You tell your model that a specific subset is belonging to is basically identified with something. So when you give it something similar, the model will be able to identify the similar thing with a variant kind of precision. We'll see what does it mean later. Unsupervised learning instead is being used when you don't know much about the data and you want to try to identify some clusters you want to split the data in different groups. But I won't spend much time on this because it's not part of the tutorial. So, supervised learning. We have usually two types of supervised learning. You have classification problems and regression. I've already done an example of classification problem, so you can identify, for example, imagine training a model that can identify cats and dogs pictures. A regression is more like, let's see, well, the house prices problem. So you teach your model that a certain house with, for example, 3-bedroom, 1-bathroom, located in a specific area has a certain cost. Now, you give the model a few of these data, and eventually, once the model is trained, it will be able to, given the characteristic of this house, the model will be able to predict the price that this house should have. But again, we won't concentrate on this. We will do we work on a classification problem for this example. So what you need to do machine learning? Well, you don't need anything particular. Just need to find a good data set. You may have one because where you work, they give you a data set to study. But what I can advise is try to find first a problem, a common problem to work on, like I did in this case. So you will find existing solution that you will use to compare your solution with those. So once you have the data, you just need any Python 3 possibly, environment using virtualenv. The libraries that I normally use are Jupyter. We will see why I use Jupyter because it's very, very practical, very useful to experiment with your code. Matplotlib or Seaborn, depending which one you prefer. Pandas and NumPy, of course, and scikit-learn. Scikit-learn is basically the framework for doing machine learning. If you want more details about the version that I use in this presentation, you will find this later in the requirements.txt. So now let's introduce the data set. Among all the data sets available, I decided to pick this one, Pima Indians diabetes data set. So I was curious about this case. Who are? So Pima Indians are a group of native Indians that were living in the south of Arizona. So you can see the map here. What happened? So a group of them moved away from the original location and moved to a different area. And they started developing an increased rate of type 2 diabetes. So why? Well, after all, they had very similar genetic characteristics, but they started having different habits. For example, when they moved, they adopted different lifestyle, they adopted a different diet, and so on. So the conclusion was that type 2 diabetes is largely preventable because it can you can incur on that if you basically don't conduct a good lifestyle. So if you don't pay attention to your diet, and plus there may be like a genetical predisposition to this, but in this case it can be preventable. So let's have a look at the data set. The data set is basically a record set of 768 women with age characteristic. I put these characteristics, some of them in bold, because you will see that those are the most important. So the plasma glucose concentration, the body mass index, and the age. How did I find that these were the most important? After all, I'm not a doctor. Potentially, I didn't know anything about this. I just was curious. I just read the story, but I didn't know anything about diabetes or this group of people. You will see how I found out that these were the most important features. So every of these column is called feature, except the last one, which is called the label. In this case, the last column it would be just a 1 or 0 to indicate that that person has diabetes or not. Okay, before we start, now you can decide to follow me and I will explain you the code step by step, or you can go to this address and grab the dataset and start the Python notebook and follow. Up to you. So I suggest you follow just my explanation, and then you will be able later to experiment with the dataset. All right, so it doesn't seem so, but this is a, a Jupyter notebook. Basically, there is a way to have a slideshow mode on Jupyter Notebook. So what you need, first of all, when you start working on a data set, you need to import your required library and do some kind of configuration. So in this case, I only need to import pandas, numpy, OS, because I need to access the file. So this is, until here, is very simple. There's nothing strange. So I just define the subfolder where I'm keeping my data set. In this case, is a subfolder called datasets. And now what I have to do. So the next step is obvious. You need to load the dataset. How you do it? So you use, well, first of all, you calculate the path, but this is just pure Python. I'm not going into details of what you probably already know how to do, probably better than me. And you use the read CSV, read_CSV method from pandas, and use that to load the dataset into a variable. So you specify that there is no header, because the dataset doesn't contain any header. You will have to add it manually. So I just, as you can see, I'm adding these columns right after I've loaded the dataset, because they will be used to display the data later in a table format. Will be used in all the graphics that I will show. So we need to some way to identify. This is not mandatory for the model. The model can reason of the data even without these labels. The labels are just a human-friendly version of the for representation. So the next obvious thing is you need to understand which kind of data you have loaded. So how you do that? Well, first, double check that you have loaded the data correctly. So we were expecting 768 rows and 9 columns. Again, 8 were features, and the last one was the label. So you use the shape method of your dataset, and you can verify that you have 768 rows and 9 columns. So perfect, everything is working. Let's go on. So you use the head method of the dataset. The head method works very similarly to the Unix head command. In this way, you can basically inspect what is inside your dataset. So let's have a look. So we have the first 5 rows. Okay, they're all numerical, perfect. And as I was expecting, I have the last column indicating me if the person has diabetes or not. Perfect, so let's go on. Now, this is the thing that I usually use to understand if there is any correlation with the data. Now, I hope I did it correctly, because personally is the, unless you're an expert on the domain of the data that you are studying, this is basically your main instrument to understand the correlation of the data. So I didn't know anything about the data before, so I had to use something. In this case, the data correlation matrix. If you call this method called core, you will plot this table. Now, this table is quite difficult to understand because first sight doesn't mean anything. You have basically the same number of rows, the same number of columns. So what does it mean? So let's try to understand. For example, let's take the rows has diabetes. I want to understand the correlation with the other columns, so with the rest of the data. For example, I see there is 0.22, 0.46, but what does it mean? So the correlation matrix, basically, the closer the value is to 1, then there is an higher correlation. The closer is to -1, the less. But again, probably this tabular format is not the best way of representing the data. So what's the best method? Well, probably a graphic representation. Okay, now it's probably easier. You see that sorry, before I meant to say 0, not -1. So you can see that 1 represents the brighter color, and 0 is the darker color. So the brighter the color is, the more correlated is that feature with the label. The darker, the less correlation. Now, okay, it's much easier. Well, probably don't know if you can see the color from the distance, but I can see that the plasma concentration of glucosium has quite high correlation, body mass index, and the age. So now, without knowing anything about medicine, anything about the correlation with diabetes, I found out that age, body mass index, and plasma glucose concentration were highly related. So now I know what can give me diabetes. So now, let's try to have a look at the data. Well, so this is the data. Why I need to visualize the data? Because I need to understand if something is missing, if there is a specific value that maybe is not obvious part of the data. So those are called the outliers, like the exceptions in your data. So I'm sorry if I have to scroll this. So you start noticing something quite strange. For example, the age. Why that there is a spike? That's strange. And especially, why there are some people with 0 body mass index? Is it possible? I don't think so. Is it possible to have 0 blood pressure? Probably not. So you notice that there is something wrong with the data. Well, this is a very, very common situation. Don't expect to find your data in a clean state. 90% of the time, your data will be in a dirty format. So you have to do something about it. You can decide to either remove the dirty data, so the dirty records, or you can decide to transform them in a different way. Now, this was my personal choice because I didn't have like thousands and thousands of records. I only have a few hundred. I only have 700 and something. So I decided, well, let's see if I can save the existing data and maybe transform the missing one and make it better. Okay, so what I did, I decided to substitute, so to replace all the 0 values with the median. Well, it's probably not the best way, but in this case, it worked. So what I'm doing here, I'm calculating the median, for example, for the body mass index, and I'm replacing, wherever there is 0, I'm replacing with this value. Now, I did this for the blood pressure, for the concentration of glucosium, for the skin thickness, and for the 2-hour SER insulin. Those are very similar. You can see the code later. So now, the most important part, once your data is ready, you need to start training your model. But before doing that, you need to do a very important operation. You need to split your data set. Why you need to split your data set? In machine learning, basically, you train your model with an average of 70–80% of your data. But as I said at the beginning, you need to test if your model works with data that it has never seen before. So how can you do that? Well, that's why you need your test data set. So you will use one part of the data to train your model, and you will use the remaining part, the 20% of the data, to test how is it performing. Let's see how to do that. Well, you don't have to do it manually. You can use this train, test, split method from scikit-learn. So the parameters are very obvious. There is a data set, you have to pass it. The test size, 0.2 means basically 20%. And random state, curious, I used the same number that yesterday Valeria used in the presentation. There is a reason behind that. Well, the most important thing is that if you want to reproduce your, in case you missed his presentation, if you want to reproduce your experiment and you want to have similar, you want to have the same results on multiple run, you need to fix your random value. That's it, basically. So, what I'm doing here, these are just pandas operation. I'm not going into much details, but basically, I'm taking the has diabetes column. I'm making a copy of that, and I'm putting in, and I'm calling the train set labels, and then I'm dropping this column from the train set because I want to separate the train features from the train labels. I'm doing the same even for the set, for the test set, sorry. So let's go on. Feature scaling. Now, we don't know yet which algorithm we are going to use. Something I found out while I was studying machine learning is that I'm not sure how this technically works, but I was reading that some algorithms don't perform very well if the data is not in the same scale. So I don't know yet which algorithm to use, and so that's why I need to scale the data. How you do that? You don't have to do it manually. You can use, again, a scaler, something that is in scikit-learn. In this case, I decided to use a min-max scaler. And how does it work? Well, you declare your scaler, you fit your train set, and then you transform your set. So all your data will be scaled to the same, in the same way. Now, what does it mean? You remember at the beginning I was showing you the table, so the original data set. Well, let's see how this data has been transformed after the scaling. So now you can see it's going from basically from 0 to 1. So now all the data is on the same scale. Now our algorithm can work properly. So let's go on. I said at the beginning, you need to choose the best algorithm before training your model. But how you do that? What does it mean? Well, you need to basically compare multiple algorithms and see which one performs better. What does it mean perform? We will see it. So I basically randomly, I must be honest, I randomly selected a few algorithms that were available in scikit-learn. I'm not even sure if I picked the best one, but I picked those, and let's see. So we want to compare these algorithms in each other and see which one works best for us. How can you do that? Well, you could do it manually, so train all different models. How many are them? So 7. Train 7 different models, try to predict, make some statistic about it, and see which one has the best accuracy. But that's a very expensive job. So let's see if scikit-learn can help us to make this thing a little easier. So you use the model selection, and you do something like this. So you create an instance of all your models, of all your algorithms. You just assign a label. We will see why. You do some configuration. Don't spend too much time on this. I will explain this later. And then, OK, I won't go into details of all these algorithms. But basically, I'm using the k-fold method. So basically, this feature is testing 10 different chunks of the data using all the algorithms, and is scoring for accuracy. So I'm interested in knowing which one has the best accuracy. So these are the results, but again, not very easy to see in this numeric format. So let's see a graphic. Using Seaborn, this other library, I'm plotting a graph. And I'm interested not in the best case, not in the worst case, but in the average case. Now, I think you can see even from the distance that the average best case is given by SVC algorithm. So yeah, OK, I'm going to choose this to train my model. So how do I train my model? Before training your model, you now need to find the best parameters for your algorithm. How you find the best parameters? In a similar way. So instead of trying them manually, you can basically decide a list of parameters you want to try. So for example, C could be 1, could be 10, could be 50, and same for the other thing. And use the grid search CV for this. So once you have done this, this feature will basically test for accuracy all these possible permutation of the parameters, and we give you back an instance with the parameters that work best. So what I will get back? I will get back the best score possible. So in my case, but it doesn't mean that it's the best result you can get. You can probably do something better. So the best score I could get was 0.76. So this is basically 76% accuracy. It's good, not that great. You can do better, again. So I leave you as an exercise. Now that you know which one are the best parameters for your algorithm, let's see how you train. Well, it's quite easy. You access the best estimator property, and you get back an instance with SVC with the best parameters. Now, I did something which I'm not pretty sure if it's correct or not, but the point is, I explained at the beginning that while you are testing if your model works correctly, you need to separate the data. But when you want to give experience to your model, you probably want to use the most data available you have. So that's why I decided to join together the train set and the test set and train my model. Once you have joined them together, you fit into the model. That's what you get back. So now you have your model trained, but how you make a prediction? Well, to make a prediction, I'm sorry. There's something. Okay, it's weird. To make a prediction, basically, you will create a new instance of your data, and you use the predict method. Using the predict method, basically, you will get back a result. And now the time over, I know. So let me get back to let's go back to the conclusion. We have a 76% of accuracy. We have found the best algorithm for it. So we have seen basically how to train our model, how to test it. The most important thing to say now is that this process doesn't have a clear path. You need to try and fail, and see what works better for your data set. Now, this was a good solution for this kind of data set, but if you're working on a different data set, you may need to do different transformation, different scaling, but the process will be very similar. So now what's next? Nothing. Well, next is you. I suggest you to use these references, grab a data set, reuse this presentation as a step-by-step guide, as a step-by-step tutorial, and try to work on some data set. I didn't learn just reading some books. I didn't learn just reading some articles on blogs. I did learn trying to work on a data set and working on, of course, on real problems. So great thank you to these two people, well, my wife, because she's a doctor, and she helped me to validate what I was saying for the medical part. And Dr. Jason Brownlee, which is a machine learning practitioner. I've been following his blog for a while now, and I must say that it's very simple. Even if you're not an expert, if you don't have a PhD in math, you can understand what is it explaining. And my colleagues who had the patience to listen to my talk a couple of times and helped me to improve it. So if you want to stay in touch, these are my contacts. So you can find me here. Yeah, thank you. Phil, time over. Is that time for a question or?
Yes.
Okay.
Yes. Okay, thank you again. It was very interesting. I hope you take a picture of the Jupyter notebook reference. Then the slide will be uploaded.
Yes, I will upload in a few.
Yeah,
In
yeah.
a couple
Just
of
be
hours.
patient. Yeah.
And
Relax.
and even an updated version of this Python notebook. I will explain later what happened.
Okay.
There was a missing part. But,
Okay.
okay.
Nobody knows.
Question.
Yeah, there's a few minutes for questions. Okay.
Thank you, Andrea. Great talk.
Hi. Thank you.
Just a quick question. I noticed that at the end you basically joined together the training and test data set again.
Yeah.
How can you be sure you haven't lost any performance if you haven't set apart a validation data set?
Good question. In this case, I didn't save the data, to be honest, because it was a very small already data set. And yeah, you're right. You're right. I could have saved something for, but this was just for the purpose of an exercise. So more than creating like the best model possible for this case, I wanted to show what are the steps before training the model, because at the end, training the model and having the validation data set is like the final part. Most of the work is usually when you are preparing the data set. So I can't stress enough how difficult is the previous part. Now we were lucky. These data set you can find on that website are, well, not in the best shape possible, but they're in a very good shape, so that can be used. You don't have to use another database to grab missing data or something like that. So they're quite in a good shape to be used. But that's not how it works. For example, if you have participated to the machine learning challenge, you have noticed that some data were missing from the data set. You have to use a separate database to fetch missing data. So that's the real case scenario. So of course, for time purpose, I could not do all these things in the same talk. But yeah, that's what happens in the real case.
Okay, one last question. I saw someone that raised the hand directly after.
La domanda devo fare in inglese per tutti o in italiano?
Va bene anche in italiano.
No, io non capisco una cosa, perché se quei dati c'erano scritti ad esempio 0 per le varie cose, tu hai detto hai messo la media, giusto, per quei dati?
Sì, avrei potuto o eliminare quei record.
Io credo, cioè...
Rispondere in inglese va bene?
Sì, sì.
Okay, the question is basically why I decided to transform some data from 0 to something else.
Yes,
right?
instead of cutting that data from the data.
It's a choice. It's a choice. What I've seen from real work, if you have thousands and thousands of records, so it doesn't affect too much your statistic, eliminate some records, then probably the best advice is to just eliminate so the dirty records, so those records which are not in a good shape to be used. But if you have like a few records, in this case 768 are not a large number of records, my advice is that you try to save your data, especially if the missing data are not belonging to columns which are relevant. So if you remember, I transformed, for example, the skin thickness and something else. Those were not really relevant for our model. So if you've seen that, you can do. It's a choice anyway. You can decide. You can use it as an experiment. So try to work on two separate data sets. The one where you choose to eliminate all the records, all the rows, well, there is 1, 0. Of course, if the 0 makes sense. And then try to work on a data set where you transform the data. You can see if your model improves or gets worse.
Okay, thank you so much again. And remember to leave the feedback on these great talks.